Okay, good morning. Thank you very much. Good morning. Thank you very much for waiting. Yes, so our crash course for probability and statistics is on, and I hope that you learn a lot. Okay. So please, if you can see my screen, let me know. Okay. If you can see my screen, let me know. Okay, right. If you can, once again, if you can see my screen, let me know. If you can't see my screen, let me also know so that I'll know how to adjust it accordingly. Okay. So let's start. And so this is last year's probability and statistics past questions. So you can see 2021 at the top here. So hopefully we have similar kind of questions, if not even the same questions. Right. And let me just use a container. I don't know what word is that, but a container. The sound. I not switched. So on the two screen. Now they show. So I learned that you couldn't see my screen, so I hope you can see my screen now. And these questions are in the description, so you can access them from there. I can start. A container contains 3 red transistors and 2 blue transistors. A transistor is joined. If it is red, so we are joined transistors. Okay. So if you pick your first one and it's red, it is kept out, and the second transistor is drawn from the container. So if you pick your first one and it's red, it means you do picking without replacement. Okay. Now, if the transistor is blue, then it is put back in the container and the red transistor is added to it. The second transistor is drawn. So first question, what is the probability that both transistors are red? What is the probability that both transistors are red? So the probability that, okay, when we pick a first transistor, it should be red. Is the total is 5, right? So that will give us 3/5. So first you have 3 red transistors and you have a total of 5 transistors that you can pick from. So 3/5. Now let's not forget that if the first one is red, it means now we are working without replacement. Without replacement. So without replacement means that now our denominator has reduced by 1. And since the second time we are picking a red ball again, now there are now 2 red balls. 2 red transistors, sorry. So this is what you have. So if you do this, you should get 0.3. 0.3. So that's how you go about it. Okay. All right. The next question. Now, this next question, please, if you know how to solve it, kindly send me the solution in the chat session, okay? Because to me, it's not really clear. Because they say that if the transistor is blue, then it is put back and the red transistor is added. I don't know which transistor they're talking about here. And the red, I don't know what this transistor is. As if we know it. Meanwhile, they've not mentioned anything about another transistor in any other box or something. So I'm not because of this statement here, I'm unable to figure it out. So please, if you know how to go about it, kindly let me know. If you're able to arrive at an answer, solve it so that we'll have access to it. Okay. The discrete random variable x has a following probability distribution. Now, with this question too, there's a mistake with this question. Yes, in the original question, which I've seen in another book, there should have been 0 with a probability mass function of 0.2. Because you can even check if you neglect this portion of it, then we are having 0.2 plus 0.2 plus 0.2 plus 0.2. We know that all our PMFs must sum up to 1. I hope you remember this. That if you sum up all our probability mass functions, we should get 1. But if you sum these, you not get 1. So it means that there was something missing, and that's 0. Okay, so let's keep that in mind. So I'm correcting the question so that we'll be able to solve it. Okay, all right. Okay, so we've been told that the discrete random variable has the following probability distribution. Find probability of x greater than or equal to 0, greater than or equal to 2. So you're supposed to find probability 0 less than or equal to x less than or equal to 2. So what this means,
this is the solution to the second question. 15 into 15. Nothing is wrong inside.
there's no,
Yeah, there's no answer. That's right. So how do you assume that was it? Assume that the first notice.
so probability of x greater than or equal to 0, greater than less than or equal to 2 means that the endpoint, so this is the same as having probability of 0 plus probability of 1 plus probability of 2. So the fact that the 0 and 2 are inclusive means I will get this. And from the table, we know this to be 0.2, this to be 0.2, this to be 0.2, and that would give us 0.6. That would give us 0.6 as our answer. Okay. Now the next part is that find E of x. E of x is the expectation. Okay, we are back. So the question says that find the expectation. Now we know that for a discrete random variable, the expectation is given by summation of x f of x. Summation of x f of x. What this means is that if I have this table, I have my x 0, 1, 2, 3, 4. I have my f of x. Your f of x is the same as your p x equals to x. So my f of x is 0.2, 0.2, 0.2, 0.2, 0.2. All right. I can find an x f of x. So x f of x, I'll multiply these two. This will give me 0. This will give me 0.2. This will give me 0.4. This will give me 0.6, 0.8. Yes, and so on and so forth. So after I have my x f of x, now the expectation E of x is given by sum of all these. So I'll sum all of them up. So if you do it correctly, you get the expectation to be 2. So if you sum, you get the expectation to be 2. Okay. So you can see from here that yes, this will give you 0.6, 1.2, so 2. So here I have 2 to be the answer. Over here we had 0.6 here. Please, the questions go upwards. So if you want number 5, we'll have to go up. So number 5 is up. All right. Number 5 says that find the expectation of x squared plus 3x. And please, let's take note of this nature of questions. These are the kind of questions that came in our mid-sem. So I think it's very, very expedient that we know how to go about them so that we will be fine. So you're supposed to find the expectation of x squared plus, let me be sure, I'm not sure, x squared plus 3x. You're supposed to find the expectation of x squared plus 3x. So here you know there's a formula we use. Now expectation has linear properties. What this means is that when we say expectation has linear properties, it means that I can split this up into a sum. So this is the same as me having expectation of x squared plus expectation of 3x. And because it's linear, it means I can bring the 3 out. So I have 3 expectation of x. So because expectation has linear properties, I'm allowed to make this expansion. Now I know the expectation of x to be 2. So here I can say, okay, plus 3 times 2. I know the value already. Now I'm supposed to find expectation of x squared. Now you must note that expectation of a function h of x is given by summation of h of x f of x. So here when I'm supposed to find the summation of x squared, it will be given by, because I'm supposed to find the expectation of x squared, it will be given by summation x squared f of x. So which means that in my table, I can form another column. So I had x to be 1, 2, 3, no, 0, 1, 2, 0, 1, 2, 3, 4. This is your x here. I had here to be 0.2, 0.2, 0.2, 0.2, 0.2. This is my f of x. Now, if you want to find expectation of x squared, you have to find x squared. What we are saying is x squared f of x. So I need to find x squared. My x squared will be given by 0, 1, 4, 9, 16. Then after I'll do x squared, I'll multiply these two columns here. X squared times f of x. So my x squared times f at x will give me some values here. So I'll do this times this. This will give me 0, 0 0.2, 0 0.8, 1.8, I think 3.2. So if you sum this together, if you sum these together, you would get, so you get 6. Yes, yes, you get 6. So this side, it means that my expectation will give me 6 plus 6, that will give me 12. So these are the two things you're supposed to know. That for discrete random variable, the expectation is given by this, and the expectation of a function h of x is given by that. Okay, let's move on, please. The next question. Oh, sorry. So they said that, hey, sorry. The next question. The discrete random variable x has probability function given by this. Find the value of k. Now, one property of discrete random variable is that the sum of the probability mass functions, the sum of the probability mass functions is equal to 1. Okay, so what this means is that for this question, I can construct a table of x against p of x is equal to x, right? Yes. And then my x values are 2, 3, 4, 5. These are my x values. And now if you check, they say that when x is equal to 2 or 3, the f of x we are supposed to use is kx over x squared plus 1. So by here I'll have 2k over 2 squared plus 1. That will give me 2k over 5. Here I'll have 3k over 10. Here I'll have, now for 4 and 5, we are supposed to use 2kx over x squared minus 1. So you have 8k over 15. And then I'll have my probability mass function to be 10k over 24. Okay. So this is my probability mass functions in terms of the k. Now, take note that we are saying that we are supposed to sum sum of f of x. This is the same as f of x, okay? So we are supposed to sum this, and this is supposed to be equal to 1 for this to be a legit probability distribution table. So let's see. So here I'm getting the sum of it is 2k over 5 plus 3k over 10 plus 8k over 15 plus 10k over 24 must be equal to 1. So you solve this equation, you can factorize k out, then do 2 over 5 plus 3 over 10 plus 8 over 15 plus 10 over 24 is equal to 1. Do you use your calculator, you get k to be equal to 20 over 33. K will give you 20 over 33. So this is k. That's okay. It's okay. All right. So I hope so here we apply the principle that when we sum all the probability mass functions, we should get 1. They gave us corresponding equations for different x values to find our probability. They give us corresponding different equations here, different equations as we can see here, to find our probability mass functions. So we use that in our table, got our f of x, we equated it to 1 and found our k. So that's what we've done here. Okay, yes. Now let's move on, please. Now the second part of the question says that we should find the probability that x is less than 3 or greater than 4. Probability that x is less than 3. So I'll stand at 3. X is less than 3 means that 2, or greater than 4 means 5. So the probability of x less than 3 or x greater than 4 is given by probability of 2 plus probability of 5. Probability of 2 is 2k over 5. Probability of 5 is 10k over 24. So this, you put in your k. So 2 over 5, 20 over 33 plus 10 over 24, 20 over 33. And that will give you the probability to be equal to 49 over 99. So what's the table? Probability of x less than 3 means probability of 2. Probability of x greater than 4 from this table means probability of 5. And all means we sum them together. We unite them, union them together. Then we fix our k that we got from the top into it. And that will help us evaluate the value of probability of x less than 3 or x greater than 4. Okay. Now, number 8 is that find the variance. Find the variance. So another formula that I have to mention, that the variance of x is given by summation x squared minus, no, summation s squared f of x minus mu squared. Summation x squared f of x minus mu squared. This is the variance equation that we'll be using. This is a variance equation that we would be using. Okay, so let's move on. So here we can actually find what our f of x is. Let's find what our actual f of x is. So in the first one, I'll put in k to be, k is 20 over 33. 20 over 33. That'll give me 8 over 33 here. Now I'll put in k to be, so next one you do 3 over 10 times 20 over 33. That'll give me 2 over 11 for this side. 2 over 11. Then I'll do 8 over 15. 8 over 15 by 20 over 33. That'll give me 32 over 99 here. So please, I'm using my calculator. So please confirm that the values I'm getting are correct. Okay. 10 over 24 times 20 over 33. That'll give me 25 over 99. 25 over 99 here. Now, we know that to be able to find our variance, we need to find our mu, right? And our mu is summation x f of x. So I have to find x f of x. So this is my x f of x table here. This side will give me my x squared f of x. So I'll also do x squared f of x. Fill it up. Okay. Now, when I do this x squared f of x here, I'll get, let's say I'll get a here. The mean, let's say I get b. So my variance will be equal to the sum. So we'll sum everything here. We'll get a minus what we'll get here, b squared. Okay. The computation it looks long, so I want to leave it. But then that's how you go about it. I believe that we can all go about it. Okay. So that's for number 8. Let's move on to number 9. Now number 9. Okay, number 9. So please move up. So the questions are up rather. So let's move up. Okay. Which of the following represents a valid probability? Please, I'll get back to you shortly. Okay, please hold on for me. Okay, let's move on, please. Number nine. Which of the following represents a valid probability table? Now, as I said early on, a valid probability table has the sum of its probability mass functions, which is this here. These are f of x here. These are x. The sum of our probability mass functions must sum up to 1. Okay, it must sum up to 1. So we'll check these two tables. Check this. And so I should go back again. I should go back. I'm sorry, I learned you couldn't really hear me. I'm very sorry. Okay, I've switched. I've switched from question nine. From question nine. Okay. Wow. So from question 9, I said that for a table to be a valid probability table, then the sum of the probability mass functions must be equal to 1. So over here, I'll check for these two tables. If I sum these probabilities here, I'll get 1. Yeah, so it means this is a legit probability table. But here, when I sum these, I'll not get 1. Let me check. Yes, I'll not get 1. There's even where 1 over 1 here. There's 1 over 1 here, so I can't get 1. I'll get something more than 1. So this is not legit. So the only table that is a legit probability table is the first one. So that's I. So that's number 9. Let's move on, please. Number 10. Which of the following represents exactly 2 heads in a 3-coin toss? So I'll check here. 2 heads, exactly 2 heads. So 2 heads, 2 heads, 2 heads, but there are 3 heads here. So this is not exactly 2 heads. But here I have exactly 2 heads here. Yes, I have exactly 2 heads here too. So the answer is I, and I. Okay. Now number 11. The question is in 11 and 12. The question is that find the probability x. Probability x, if you check, is moving from the starting point to a1. So probability x is given by probability of a1. This a1. So it's given by the probability of a1. Now the next question was for us to find the probability y, and I said that think of it this way: you are at this point, you want to get here, you want to come after the y, you have to move through this line and come here. So y is the probability of this point is b2. Okay, this point is b2. So it's the probability of b2 given that you have gone through a1. It is y. So y is the conditional probability. I can't get here without. Sorry, please hold on. There's little noise here. The noise has left, so we are back. So y is the probability of b2 given that a1 has occurred. If I want to come to b2, I'll have to move through a1. A1 has to happen before I can come to b2. So that's what y is. So which means that our number 11 is A, and our number 12 is C. Number 13. Suppose x is a Bernoulli of theta, where theta is unknown. Which of the following is a correct statement? Now, Bernoulli is a type of discrete uniform distribution. Okay, so we have the Bernoulli, the binomial, Poisson, and all those ones. So first thing is that the random variable is discrete. Yes, the space for theta is discrete. So the answer is A. It's for discrete. It's not for continuous. So the answer is A. Let's move on. Number 14. Let A and B be 2 events. Let A and B be 2 events. Suppose that the probability that neither event occurs. Suppose that the probability that neither event occurs is 3/8. So probability that neither of them occurs is 3/8. So probability that neither A occurs nor B occurs is 3/8. What is the probability that at least one of the events occurs? At least one of the events occurs. So here I use this relation. Probability of A bar intersection B bar given by 1 minus probability of A union B. So in the question, I am supposed to find the probability of A union B. That is the probability of at least one of them occurring. So my probability of A union B is given by 1 minus probability of A prime intersection B prime. That'll give me 1 minus 3 over 8, and that will give me 5 over 8 as the answer. So the answer here is 5 over 8 here. Please, I hope it makes sense. So it's a formula. The probability that neither event occurs given by this: A will not occur and B too will not occur. Now, at least one of them occurring is the union. So I'll just, this is given by 1 minus this, and then I'll find this P of A intersection B, which is what I want. The next question, let C and D be two events. Suppose that probability of C is 0.5, probability of C intersection D is 0.2. Probability of C union D complement. Probability of C union D complement is 0.4. What is probability of D? Now, over here, I can use the addition rule. I can say that probability of C union D is given by probability of C plus probability of D minus probability of C intersection D. Now let's see. I have probability of C given 0.5. Yes. I have the probability of the intersection given 0.2. Fantastic. Now I want to find probability of D. Okay. What else do I have that can help me? I'm supposed to find probability of C intersection D, right? C union D. Now I know that probability of C union D all complement. So probability of C union D all complement is given by 1 minus probability of C union D. So this is another equation that we must keep in our minds. So this implies that probability of C union D is given by probability of C union D 1 minus probability of C union D all complement. So I was given this in the question as 0.4. So this will give me 0.6. This would give me 0.6, which I can now put at this part here. I hope I was making sense. So now I can say that I'm using probability of C union D is equal to probability of C plus probability of D minus probability of C intersection D here. So I have this to be 0.6. I have this to be 0.5. I'm finding this probability of D here. This is what I'm finding, minus the intersection 0.2. So I'll make P of D the subject here. When you do that, when you make probability of D the subject, you are going to get 0.3. So our answer is 0.3. 0.3. So it's very important to know this equation. Very, very important to know this equation. These two equations are very, very important. Very, very important. Okay. That's number 15. Let's move to number 16. Let's move to number 16. Number 16. A test is graded on the scale 0 to 1 with 0.55 needed to pass. With 0.55 needed to pass. Student scores are modeled by the following density. So this equations is a PDF, our probability density functions for the various ranges. What is the probability that a random student passes the exams? Now, if you check this, the score is from 0 to 1, and you need 0.55 before you pass. So this question is the same as they saying that find the probability that someone's score is greater than find the probability that someone's score is greater than or equal to 0.55 and less than or equal to 1. So this see how the question is put. Very, very interesting. We want to find the probability that someone passes the exams, and they say that the pass mark is 0.55. So therefore, someone who passed the exams is someone whose score was between 0.55 and 1 inclusive. All right. So now I have to find this value. So I'll check 0.55 and 0.1. In my PDFs, which range does it fall in? It will fall in this range. So this is the same as me saying that, okay, find integral, because we know that PDFs are integrals, right? It's integral from a to b f of x dx. These are, so let me write it well. Let me write it well for all of us. Probability, a certain variable specified from a to b, is given by integral from a to b f of x dx. So you're supposed to find, I'm supposed to find the probability. The probability x between 0.55 and 0.1. This is the same as me saying that evaluate the integral from 0.55 to 1, sorry, to 1, 1.0 to 1 for an f of x in that range. The f of x in that range is 4 minus 4x. So of 4 minus 4x dx. So here you can use your calculator here. Integral 4 minus 4x from 0.55 to 1. That would give you 0.405. 0.405 as the answer C. Alright, so that's how you go about it. Please, I hope you don't have any questions. I hope I'm making sense. If you have any question at all, okay, I already says that question 10 is I only, because the case 3 does not equal the event exactly to, okay, it doesn't have all the, okay, let me see, let me go back to the question. Okay, already, thank you very much for your contributions. Here's the question. In 3 tosses of a coin, which of the following equal the event exactly 2 heads? Okay, so it should be I only, because this one doesn't have all the possible outcomes. Sure, it makes sense. It makes sense that way. So it should be B. Please, if you have any counter argument or any suggestion to add, please kindly add. Okay. Right now, let's move on. God bless you, Arizi. Please, so yes, so please, that's what we should be doing. If you have any problem, if you have any contributions, any problem with the solutions, please kindly tell us so that we will all be aware. Okay. Okay, let's move on, please. Yeah, so that's it for this question. The next question. Suppose that Suppose x is a random variable with cumulative density functions. They've given us CDF. Please be careful. They've given us CDF. Now, initially, if you don't read the question, you think this is a PDF because this is small f. Because usually CDF is represented by a capital F. But they said that this is our cumulative density function. Please kindly hold on. Kindly hold on for me. I'll be back shortly. Okay, thank you very much. We are back. We are back again. We're talking about number 17. All the best. I pay watching. Pay watching. Number 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 17. So suppose x is a random variable with cumulative density function given by this. Find the expectation of x. Now we know that the expectation of because this is a continuous variable, it's a continuous random variable, is given by integral x f of x over the entire limit minus infinity to infinity dx. Okay, where our f of x here is our probability density function. Now here we're given the let me use capital F. It's confusing me. Here we're given the cumulative density function. So my capital F of x is given by, I'm expanding, so it's given by 2x minus x squared. Okay, my capital F of x is given by 2x minus x squared. Next formula to keep in mind, small f of x is given by d dx of capital F of x. In words, the probability density function is given by the derivative of the cumulative density function. So let me come here. So my probability density function is given by the derivative of my probability mass function, of my cumulative density function, sorry. So I'm getting d dx of 2x minus x squared. So I'm supposed to differentiate with respect to x, 2x minus x squared. So my probability density function is given by 2 minus 2x. I said that also we know that our e of x is given by integral x f of x, where f of x is our probability density function. So here I can now say, okay, I'm supposed to now, so my expectation is given by integral over the entire range. It ranges from 0 to 1. So integral 0 to 1 x multiplying f of x, which is 2 minus 2x dx. So when you get here, calculator work, integral from 0 to 1, 2x minus 2x squared dx. So when you put it into the calculator, integral 2x minus 2x squared from 0 to 1, that'll give you 1 over 3. 1 over 3. So you get 1 over 3 as the answer. So here, what you would have likely missed is the fact that this is a cumulative density function, and you are supposed to first change it to its probability density function, because we know that for the expectation is x f of x. This f of x here is the probability density function. So I'll find it and then I'll move on from there. Okay, let's move on. Now you're supposed to find the probability of x less than 0.4. So probability x less than 0.4. Now if you check the range, for our range, our area is what? Let's say, let me just draw any curve. Okay, this question is like, we have like any curve like this. You have any curve like this, that's starting from 0 and ending at 1. This is the curve we have. Is it find probability of x? So let's locate 0.4 here. So they want us to find the probability of this. So this is the area, right? So this will be given by integral from 0 to 0.4 of the function of the probability density function which we found. We found the probability density function to be what? Found it to be small f of x. What was small f of x? Two minus 2x. Okay, 2 minus 2. We found it to be 2 minus 2x. So this 2 minus 2x dx. So let me see. Integrating 2 minus 2x from 0 to 0.4. Let me see. 0.64. So the answer is 0.64. The answer is 0.64. So that's how we go about it. Number 18. Okay, so let's move very fast. Okay, let's go a little faster. Number 18 is down. So when we see such questions as this, I think we might skip. So we've done number 18. So number 19. So this one, compute the mean and variance for a random variable whose distribution is uniform on interval m to n. So we have a uniform, let's say if you're talking about, we have a uniform distribution over a certain interval. Sure. Here the formulas are fixed. You have to please just memorize these formulas that for a uniform distribution, this is the mean. Variance. This is a mean, this is a variance. That's all. Number 20. Please, number 20, a statistic is. Please, if you know the answer to this, kindly let me know. Okay, when I googled it, I saw some portion they were saying the statistic is a sample characteristic. At other points, I saw that it said it's a population characteristic. Yes. So it's, of course, it's one of those answers. One of those answers. Don't know which exactly, but let's move on. Let x have range 0 to 3. So x ranges from 0 to 3 and has density function. So it has PDF. So this is a continuous random variable question. So we have the PDF to be k x squared. Okay. So we know that integral over the entire range of the function is equal to 1. Just like how for the discrete, we said that discrete summation of all f of x is equal to 1. Integral of f of x over the entire range is given by 1. So here I can bring k out and do integral from 0 to 3 x squared is equal to 1. This will give me 9 is equal to 1. When I put this into the calculator, so I'll get my k to be equal to 1 over 9. So this will be okay. This will be okay. 1 over 9. Now, the next question says that find the cumulative distributive function, the CDF. So you see, we learned that if you have CDF, capital F at x, and you want PDF, you differentiate. Now I have PDF, I want CDF, so I'll integrate. So my capital F at x is given by integral, okay, from the lowest limit minus infinity to a certain x value, f of x dx. So let's see. So let me write well. So I'm saying that if you have PDF small f and you want big F, your big F of x is given by integrating from the lowest limit to a certain x value, f of x dx. So for this question, I'm supposed to integrate. My lowest limit here is 0. to x. I found my f of x to be I found my f of x to be 1 over 9. My k is 1 over 9, so that's 1 over 9 x squared dx. I'm supposed to integrate this. So here, if I do this integration, I'll get 1 over 27 x cubed from 0 to x. So I put in my upper limit x, I'll get 1 over 27 x cubed. 1 over 27 x cubed. So the answer here is x cubed over 27. That's this. Okay, let's move on. Number 23. 23. Oh, so 23, you are supposed to compute the expectation for y. So as I said, you know that expectation for a certain function, let's say h of x, is given by integral h of x dx. h of x f of x dx given by integral h of x f of x dx. Kindly follow here. So here my h of x is y. If we check the question, we're given y to be x cubed. So x cubed multiply f of x is my probability density function, which I got to be 1 over 9 x squared. So I'm supposed to integrate this over the limits 0 to 3. When you put this into the calculator, you are going to get an answer 27 over 2. 27 over 2. Find the explicit integral. Find the explicit integral of var y. Find the explicit integral of variance of y. So we know that variance of y is given by, let me say, variance of x, right? Variance of x is given by integral x squared f at x minus the mean squared. Yeah, so I have to find an expression for this. Now, variance, so as let me write a general expression. Variance of h of x is equal to integral of h of x squared f of x dx. So here I was giving my h of x to be y, which I know to be x cubed in the question. So I'm supposed to do integral x cubed all squared times f of x, which I got to be 1 over 9 x squared dx. This will give me integral x to the 6 1 over 9 x squared. Right? Then we said that there's supposed to be a minus mean squared here. Minus mean squared. So the answer is this minus the mean squared. This minus the mean squared. This minus the mean. So let me say we are putting the y. So mean of y. Okay, all right. So the answer, as we can see, is this. These two are very close, but here is mean of y squared. No, it's supposed to be mean of y. Like we want the mean of y squared. So the answer is D. Number 25. 25. Find the probability density function for y. Find the probability density function for y. So we got the CDF. We got the CDF, that's capital F of x, to be equal to x cubed over 27. This is what we got. All right. Now this one, you do something. You do something. You compare. Okay. You have to compare. I'm coming, hold on. You have to compare, yes. So this is my f of x. This is my f of x, right? My capital F of x given by s cubed over 27, right? Let me come here, right? So I'm having my f of x to be equal to x cubed over 27. Now my CDF for y, I can replace this x cubed with y, right? Y over 27, because we're given that y is equal to x cubed, so I can just do this change and express it in terms of y. Now we also know that if I have CDF and I want to find PDF is ddx of CDF. PDF is ddx of CDF, right? So this means, so here y, in terms of y, so d dy. So I'm supposed to find d dy of y over 27. If I differentiate this, I'll get 1 over 27. Okay. So the answer is 1 over 27 over the entire range, 0, 3. So that's it. That's 25. Let's move on, please. There's 26. Okay, 26 is a question on its own. Okay, suppose x is a random variable with expectation of x 5, variance of x. So what is expectation of x squared? So we know that variance, okay, variance is given by, variance of x is given by summation x squared f of x minus mu squared. So minus mu expectation squared. So this is the equation that we use to solve this question. Okay. We've been given variance, fantastic. We've been given mu, a expectation of x, we can square it. Now this is, don't forget that I wrote that expectation of a function h of x is given by the summation h of x f of x, right? So here I'll be moving from here, right? I'll be going backwards here. So if I have summation, this is my h of x f of x, this is the same as me having this of s squared. My h of x is s squared minus expectation of x all squared here, then my variance of x here. So I'm supposed to evaluate this expectation of x squared. I'm supposed to evaluate the expectation. Supposed to evaluate the expectation of x squared. So I'll make expectation of x squared the subject. So I'll make expectation of x squared the subject. That'll give me expectation of x squared is equal to, I'll move this here, variance of x, which is 2, plus mean squared, 5 squared. That'll give you 27. 27 here. Alright. Whoa, hold up. Come on. Come on. Okay, let's move on to number 27. Let's move on to number 27. A Seletal supermarket. At Seletal supermarket. Okay, so you can say at Elisa, okay, so this is the name. So at Elisa supermarket, 60% of customers pay by credit card. Find the probability that in a randomly selected sample of 10 customers, exactly 2 pay by credit card. We say we should use binomial distribution. It's a hint. You can choose not to use it. I don't know how you do without using it. So here we've been given the probability. So if this is a binomial distribution question, we know that we need a p, right? Probability of a success. So in this case, our success is when someone pays by credit card. So our success, which is p, our success p is equal to 0.60%. This is supposed to be percent. And our failure kill is given by 0.4. So we are supposed to find probability of x is equal to 2, right? Exactly 2. Probability of x is equal to 2. And this is given by the general expression for the PDF, let me say PMF, probability mass function for binomial distribution is given by n combination x p to the x q to the n minus x. So this p of x is equal to x. So if I'm supposed to find p of x is equal to 2, and my n, they said for 10 customers selected 10, my n is 10, my p is 0.6, my q is 0.4. I'll substitute. So 10 combination 2 0.6 squared 0.48. So you put this into your calculator and you get the answer to it. Okay, that has to be 0.011. 0.011. The next question goes on to say that find the probability that a randomly selected sample of 10 customers, more than 7 pay by credit card. More than 7, so p of x greater than 7. So if we are taking 10 and more than 7 pay by credit card, it means that we are talking about when x is 8, when x is 9, when x is 10. So you do individually for this using the n combination x p to the x k to the n minus x for each of them, each of the variables. So when you do it correctly, you get 0.17. Okay, so kindly do it and get the answer. Number 29. So yeah, so this is a continuous random variable with PDF. You're supposed to find the value of k. So we know that integral over the entire range of PDF is equal to 1. So you do this, you get the answer to be 3/16. Okay, we've solved similar question like that. That's why I'm not solving it. Then find probability of x less than 1, right? So x less than 1, the lowest range here is this. So if this is the same as saying probability 0 less than or equal to x less than 1, so it means I'm supposed to evaluate from 0 to 1, right, of the PDF dx. When you do it correctly, you get 0.3125. And the last question says that we are supposed to find number 31. 31, we are supposed to find expectation. So we know that the expectation is integral over the entire range x f of x dx. So please be familiar with the formulas. The formulas we are using them. So just make sure that you are familiar with them. Okay. The next question. The random variable x is distributed over a certain binary 7 0.2. Now when they write a binary like this, what they bring is the n, the number of trials, and the second one is our success P. So in this question, they've given us our n to be 7. So this is a question where our n is 7, our P is 0.2, our Q is 0.8. We're supposed to find P of x is equal to 3. So same, n combination 3. I'm skipping the formula, but you should be able to see P exponent x Q exponent n minus x. So 7 combination 3 times P exponent 3 times Q exponent 4. That will give us 0.115. Thank you. I'm looking here. Then for this one, P of x greater than 1 less than, so it means greater than 1. So you're talking about P of x is equal to 2, P of x is equal to 3, P of x is equal to 4. So we'll repeat the same procedure to find the answer. Okay. Number 34. What is the area under a conditional cumulative density function? What is the area under a conditional cumulative density? Okay, let's solve this one so that we'll get the answer. Let's solve this so that we'll get the answer. So that we know that we are choosing an answer. So that if it comes to be, So we solved for x is 3 already. We know x is 3. So let's solve for x is 2. So x is 3 is x to be 7 combination 2, 0.2 exponent 2, 0.8 exponent 5. So you get this one to be 0.27. So you get 0.275. We had it one to be 0.115. Then the last one, when is 4? So 7 combination 4, 0.2 exponent 4, 0.8 exponent 3. So I'll sum them together. This plus 0.115 plus 0.275, 0.419, 0.418. So this is the answer. Number 34. The area under a conditional cumulative density function is 1. Okay. Yes, so if you have a curve like this over the entire range a to 1, that's accumulative. You're accumulating everything, and that will give us 1. We say that this f of x is equal to 1. Yes, that will give us 1. So let's move on. 35. What will be the probability of event J? So probability of J, if H denotes its complement. So we know that probability of J is given by 1 minus probability of J complement. So if J complement is H, then talking about this. So B, 35. Let's move on. 36. A variable that can assume any value between 2 given points is a continuous random variable. See, that will give you a range. Let's say 0 to 3 like this. But any range at all in between is continuous. Next question. If A and B are two mutually exclusive events with P of A greater than 0 and P of B greater than 0, then it implies they are independent. That's not true. That's a false statement. Well, for mutually exclusive, P of A intersection B is 0. For independent, P of A intersection B is given by P of A times P of B. Independent. So this is independent, this is mutually exclusive, so they can't be the same. Let A and B be two events such that the occurrence of A implies occurrence of B, but not vice versa. Then the correct relation between P of A and P of B is B. This one is a notation. They are just notations. Okay, I don't know how to explain it, but it's like it's a notation. I think I'm improving, but yeah. Number 39. In a sample space S, if probability of A is equal to 0, then A is independent of any other event. In a sample space S, if probability of A is equal to 0, then A is independent of any other event. I think that's true. Okay, but let me look out for any questions. Is there anyone has any question for me? No. I read it. Number 19. Let me go to number 19. I read it, please. I'll answer your question, okay? C and D are not the same. If you check how the squares are, the C is like expectation of S y squared, but we want expectation of y squared, like the mean of the function before the square comes. So the answer is the one that has the mean of everything squared. So number 19. It was number 19. Okay, sorry, I read it. I was answering the wrong question. Number 19. It has to be the upper limit minus lower limit. Yes, even though you get the same answer, but then see, you're talking about like correct notations, right? So if you have A to B, your variance is n plus n over 2. And you mean like you must show that it's a subtraction. So it's your upper limit minus your lower limit, all squared over 12. Although yes, square of a negative number is the same thing, but then intuitively its origin is that it's not that its origin is the difference between them. That's like big minus small. Okay, thank you very much. Please, number 39. I'm thinking as I should. I believe if you have any other, if you have any other, I'm thinking it's true because that's true. That's true. And that is true. See, yeah, because if the probability is 0, then it means it doesn't depend on anything. So the answer is true. Okay. Number 16. Number 40. Number 40. Given that 15 permutation R minus 1. So that is so that n permutation R is given by n factorial n minus R factorial. So here, kindly hold on for me. Let me check something. Okay, we are back. We are back. Number 23. That is it. Okay, number 23. Let me check number 23. I think some controversy about number 23. Let me be sure what it is. 23. 23. The expectation of h of x is always equal to integral over the entire limit. H of x, f of x is fixed, dx. So we know our f of x, right? We know our h of x, so we just put it inside. So h of x is x cubed, f of x is 9x squared. So you put inside and get your 27 over 2. Sure, sure. Okay, Perry, thank you very much, Perry, for thank you very much for clarifying. Okay. I like that we are together as one, helping each other, and it's the best thing that's happened to electrical this semester, and even any other people, any other person who has been following us. All right, let's move on. I was at number 39, so now we are moving to number 40. So permutation. So 16. Okay, I'm coming, please. Okay. So let's move on. So we've been given that 16 permutation r minus 1 over 15 permutation r minus 1 is equal to 16 over 7. Okay, let's move on. So we are supposed to find the value of r. Find r. So we know that this one can be expressed as 16 factorial over 16 minus this. So that gives me 16 minus r plus 1 all factorial divided by 15 factorial over 15 minus r plus 1. So I'm doing this. I'm doing 15 minus r minus 1. That's what I'm getting, minus r plus 1. In case you didn't realize, it's equal to 16 over 7. So over here, I'm getting 16 times 15 factorial over 16 minus r plus 1 factorial. No factorial here. Let's move on. So multiplying, so I'll subtract 1. So that'll give me 15 minus r plus 1 factorial. Then here, a reverse, right? So that'll give me 15 minus r plus 1 factorial over 15 factorial. It's supposed to be equal to 16 over 7. Things are looking at us ready to be cancelled. This over this, this over this. So we'll come and get 16 over 16 minus r plus 1 is equal to 16 over 7. This can cancel this, right? So I'll be left with 1 here. So if I cross multiply, I get 16 minus r plus 1 is equal to 7. So minus r is equal to 7 minus 16 minus 1, minus r is 7, minus 17, minus r is minus 10, r is 10, r is 10, r is 10. Let's move on. 4 fair coins are flipped. If their outcomes are assumed independent, what is the probability that 2 heads and 2 tails are obtained? 2 heads and 2 tails are obtained. So we're talking about 4 coins being flipped, right? It's the same as me flipping two coins. So I'll just draw a table for my sample space. Okay. Why? Yeah. So let's say my first coin, I have this T T T H H T H H. Second coin, I have T T T H H T H H, something like this. So I get T T T T T T T H T T H T T T H H. Yeah, I get T H T T T H T H T H H T T H H H. It's a lot of work. H H T T T H T T H H T H T H H T H H. Last one I'm having H H T T H H T H H H H T H H H H. If we must go back to class 3 to get question correct, we will do that. So that's what we have done. We have taken all the time, whatever it takes necessary to score everything. All right. So we want to get what? 2 heads and 2 tails. So let's check. No. So if anybody see 2 heads and 2 tails, it's equal. So this 2 heads and 2 tails, 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 2 heads and 2 tails. 1, 2, 3, 4, 5, 6. So we are getting 6 over total sample space 16. So that give us 3 over 8. 3 over 8 over 41. Forty-two. The mean and variance for a multinomial distribution is given by the mean is NP, and the variance is NP. So NP like I, right? I'm coming, okay. The mean. Okay, let me see. Let me see if there are any questions. I should go to the question. It's not there. Binomial. Two. Two. Please hold on. Okay, we are checking something. is you are back. So the mean is, so we know that if it were binomial, okay, the mean is NP and the variance is NP 1 minus P, right? Now multinomial means that you're talking about two, more than two. So here, this is like of I, like where I can be 0, 1, 2, 3, 4. Let me say 1, 2, 3, 4. So of I here. The answer is A. Number 43.
Right now, so equation C. So,
Items in a large lot under inspection are subject to two defects. A judge that 60% of the items are defect free, whereas 30% have a type X defect and 10% have type Y defect. If 10 of these items are randomly selected from the lot, find the probability that 5 have no defect, 2 have type X defect, and 3 have type Y defect. Please hold. Okay, we are back. Please, number 43 is confusing me a little, so but we'll solve it. So let's just hold on for some time. Okay. Number 44, the preamble. Suppose that a car dealer has 30 cars available for immediate sale, of which 10 are classified as compact cars. What is the probability that of the next 5 purchases from these cars available for immediate sale, one will be a compact car? One will be a compact car. So here, the total number of cars, n, is 30. So the total number of cars are 30. Then, so number of cars 30. The number that are compact is 10. Then, so this question, this is a, how do we call it? Sure, let's move on. Okay. And then they say that what's the probability that of the next 5 purchases from these cars available for immediate sale? So we are selecting 5. Okay. Yeah, so there's a formula. The formula is given by summation x is equal to 1 to 5 ax. Our a is this compact here, so a x n minus a over n minus x all over n. So here you can do it this way. A simple way of going about it. Okay. Is that you say that a dealer has 30 cars, right? For which 10 of which are compact cars. So let's say the probability of compact cars, probability of it being a compact car is, let's say, 10 over 30. Probability of it not being a compact car is 20 over 30, right? So what is the probability that of the next 5 purchases, one will be a compact car? So here you can just use, you can think around it. So you can use that, okay, the first car is a compact car, second car is not a compact car, third car is not a compact car. You got what I'm trying to say? Or first car is not a compact car, but second car is a compact car. You get it? Or first car is not, second car is not, but third car is. So you just use those permutations, you just combine it that way. So I hope you are getting it. Yes. So I've not solved it yet, but so you can use this formula. So if you didn't get the answer, kindly tell me so that I'll choose it. Okay. You can use this formula here, or you can also think around it that, okay, we are saying that 30 are compact cars. What is the probability of the next 5 purchases from these cars available for immediate sale? One will be a compact car. So either the first is a compact car, second is not, third is not, fourth is not, fifth is not, or first is not, second is, third is not. So just do those permutations. Okay, and then you get the answer out of it. Yeah, so this way of thinking about it means this one you're doing without replacement. Okay, so if here is 10 over 30, this place has to be 20 over 29, then 19 over 28, like that. But better to just use the equation so that you go fast, so you'll be fine. Okay. All right. So I believe that all 5 cars will be compact cars. Now all 5 cars will be compact cars. So the first is a compact car. Second is a compact car. Third is a compact car. Fourth is a compact car. Fifth is a compact car. So if you get 0.0018, 0.0018 as the answer. Yes. So you can apply it, you can think of it that way. Okay. Let's move on. Please, if you need let me check if anyone needs clarification on this question. Don't come in, please. 42A. Where is 42? Yeah, 42A. Okay, sure. 43. Shit. 11 and 12. I found. Okay. So let's move on. Okay, let's move on, please. Just type a portion of the question. So a large consignment of items contains probability of defective. So let's move on. Number 46. Probability of defective is 0.1. Okay. Probability of not being defective is, so here I can just do this. Let me erase it. So here we've been given RP. So RP is the fact, P is the exact. You see, they say items are drawn until a defective item is found. So that's like our success is when we find a defective item. Okay. So RP is 0.1. Find the probability that less than 4 draws are required. So probability that X is less than 4. This is the same as saying that P of X is equal to 1, P of X is equal to 2, P of X is equal to 3. Right? And this is a geometric, because we are geometric means that what? Geometric is number of trials until a first success. So here, like here, when we do one trial, we'll see a defective. Here, we'll have to do 1, 2 before we'll see a defective one. Here, we'll have to do 1, 2, 3 before we'll get a defective. So geometric, what's the concept of geometric? Let's talk about geometric. So geometric is geometric distribution, a type of uniform discrete distribution. Okay, we are talking about X trials until a first success occurs. Okay, so if we define something as geometric, all we need is just its P, it's just its success. Okay, so the probability density function of a geometric function is given by P Q to the power X minus 1. P Q to the power X minus 1. So if I want to find P of X is equal to 1, so in this question we are supposed to do for X is 1, 2, and 3. So 1 means that my P was 0.1, 0.9, exponent 1 minus 1, that's 0. Then P of X is 2 is 0.1, 0.9, 2 minus 1, that's 1. Then P of X is 3 is 0.1, 0.9, 3 minus 1, that's 2. So you sum all these together. 0.1 open bracket, 0.9 plus 0.9 squared. So the answer is 0.271. If you do it correctly, you get 0.271. Thank you, Holy Spirit. Okay, let's move on. Which of the following fits the definition of negative binomial distribution? So we said that geometric is number of k trials till first success, right? Negative binomial is number of successes in a certain number of trials. So number of trials until k success, number of trials after k success, number of trials depends on success of operation, number of trials needed to complete the process. So it's like, let me see, negative binomial number of trials until r successes occur. So it's number of trials until a number of successes occur. No, not until k success. Or so B. Okay, number of trials until k successes have occurred. So B. 48. The number of power. Let me see if someone has a question, please. Okay, no question yet. The number of power surges in an electric grid has a Poisson distribution with mean of 1 power surge every 12 hours. So every 12 hours, the mean, which is given by theta, is 1. What is the probability that there will be more than 1 power surge in a 24-hour period? So if there's 1 power surge in 12 hours, then 24 hours, there will be 2 power surges. So Poisson distribution allows us to make these direct relationships. Okay. Then now we can do this. What's the probability that there will be no more than 1 power, not more than 1, meaning that talking about p of x equals 0 or p of not more than 1, right? So 1. So p of x is equal to 1. So the Poisson equation for the Poisson for p of x is equal to x is given by e to the power minus theta to the power x over x factorial. So here first we'll do for p of x is equal to 0. Okay. Not forgetting that our theta is equal to 2 for the 24 hours. So e to the power minus 2 times 2 to the power 0 over 0 factorial. This is e to the power minus 2 here. Then p of x equal to 1 is given by p of x equal to 1 is given by e to the minus 2 once again times 2 to the power 1 over 1 factorial. So this is 2 e to the power minus 2. Yes, so I think we can get e to the power minus 2 multiplying 1 plus 2. So let's check. E to the power minus 2 in bracket 3 0.406 is the answer. Okay. Yes. So usually Poisson will mention it. So Poisson, all you have to know for Poisson is that p of x equal to x is given by e to the minus theta to the power x over x factorial, where this our x is our average value. And for Poisson, note that our expectation is our theta, our variance is our theta too. So for Poisson, the expectation and the variance coincide at the same point. Okay, so that's one thing you must know, that for Poisson, expectation and variance coincide at a single point, and the Poisson at any point is given by this relationship, x p of x equals to x. Sure. So we didn't do exponential distribution, so I'll skip it. Okay, let's move on, please. Yeah, so we skip. So number 50 is normal. Normal, use the normal table or a normal. I think you can also use the calculator. So you kindly Google it, like how to use calculator to find the normal distribution. Okay, you can use calculator to do it. All right, let's move on. So I skipped a question. I skipped number 43. Yes. So number 43 is a multinomial question. Okay, it's a multinomial question. So we are supposed to evaluate it as such. So multinomial question is they are very, very simple to do. You just all you have to do is just a formula. Let's move on. So this is the last question we'll solve. So if you have any question, please do what to ask before we finish solving this one. Okay. So we've been given probability of defect free. Probability of defect free. Let me call that one P1. That's given by 0.6. We've been given type X defect. So we have probability 0.3. So let me call this defect free, X defect, Y defect. That's P3. That's my P3 given by 0.1. We're also given the number of defects. So let me see. Items in a large lot under inspection are subject to 2 defects. It's judged that 60% are defect free, 30 have type X, and 10 have type Y defect. If 10 of these are randomly selected, find the probability that 5 have no defect. So we want a certain number, right? So a number, we want a certain number with no defect to be 5. Let me call our N1. Type X defect to be 2, and type Y defect to be 3. So we have all these parameters. So the multinomial distribution will be given by, it's always given by n factorial over n1 factorial, n2 factorial, n3 factorial times P1 exponent N1 times P2 exponent N2 times P3 exponent N3. This N is a total, which we're giving N to be 10. N was 10. So you just put inside 10 factorial over 5 factorial, 2 factorial, 3 factorial times 0.6 exponent 5, 0.3 squared, 0.1 cubed. So it's formula work. When pushing inside, you should get 0.01760. Light weights. Once you're able to recall the formula, you'll be fine. Okay, so that's it for number 43. Yeah, so I said please Google how to use calculator to do the normal values. So you know how to use a table. But it says will give us a table to use. So that's number 50. Alright. So yes. Any question for me? No question for me so far. So let's see. So we started from here. So this is number 2. The question is some way. But if we neglect this portion of the question, then we can solve it. Because we can take it as if we can take it like they said the second is red. So that one is let's forget this question. So after we came to this question, we saw that for probability distributions, the sum of the mass function should be equal to 1. So we use that one to find all of them. Then we came to number 5, where we said that you can apply linear properties. So I can do expectation of x squared plus 3 times expectation of x. Okay. Then we saw discrete random variable. So we said that once you put in the values and sum them, you can equate 1 and find k. Then yes, so we've gone through. Hopefully this session is very helpful in writing our exams, and it has touched on a lot of things. It has touched on almost everything actually. Yeah, it has touched on a lot of things. It has touched on almost everything we did even. Yeah, so the Lord be with us all. Remember to pray before you start work. Pray to God to help you. Yes, and once again, thank everyone who is making this possible. Our president, Pepra Kwame Frimpong, our technical guy, Papa Kwanzaa, and all the academic teachers. Thank you all for listening and have a wonderful day. Bye.